Alrighty, so it is 7:05. We will go ahead and get started. Welcome to the MedMath review. In the beginning of every semester, regardless of whether you are just starting the program or finishing the program, in addition to every nursing job that you will have down the line, you will be required to sit for a MedMath exam just to keep everyone safe. I've worked with nurses who have been working forever and they also take the MedMath exam. And it's like, oh, drip ratios, fun, what's that? So I don't know if you guys have access to the records file for the MedMath review. Feel free to pull it up. I'm going to share my screen so you guys can see it. We'll go through it. I'll point out different things that I found really helpful. There are different ways to attack or just approach a MedMath problem. Everyone has their specific way to do it. I encourage you to find the one way that works for you and to stick to it, because if you just try too many things, sometimes it just gets more confusing. So let me know if you can see my screen. I have not shared it yet, so hang tight. Alrighty, so what you're looking at right now is a document that I created during my very first semester at Rutgers Nursing. And these are the ratios or the proportions that you need to know. If it's on here, you need to know it. If it's not on here, then you don't need to know it. I just want to take a peek and make sure that you guys can see it. If someone could just put in the chat if you guys are able to see the document, that would be awesome. Okay, perfect. Thank you. So 1 ounce is going to equal 30 ml. The times that you will be seeing an ounces related question is regarding patient dietary diets. So a diabetic or someone who's on fluid restrictions. So you'll have those ratios there. Or when you're doing parent education for a pediatric patient, you'll need to know the ounces into ml. 1 teaspoon as well. When you're teaching patients, they're going to throw that in there, as well as the 1 tablespoon. So it's 5 ml per 1 teaspoon and 15 ml for 1 tablespoon. So that's 3 teaspoons in a tablespoon, and you'll see that conversion. The most classic, famous one that you will have is the kilogram into pounds. And it's important to kind of get it right, because what you'll see is that your professors or elsewhere, they'll put the patient in pounds and then they'll ask you the question. And the ratios are going to be kilogram based. So you'll first have to convert the patient's weight into kilograms. The next ones are IV proportions, and that's just figuring out how to set or configure your pumps, and we'll go through those later. Macro drip and micro drip, some institutions you'll have to do this, some of them you won't. In a pediatric hospital, it's very likely that you will never have to use macro drip or micro drip, but in adult hospitals, they count drips because IV pumps are sometimes hard to come by, especially during COVID. Nurses were counting drips, and so you will come across those. Any questions so far on the chart that I have here? Okay. We will flip over to the PowerPoint presentation. Okay, so it's a self-guided workshop, so you should have received it from OAS. It should be accessible on the site as well. And it is a PDF document that you'll be able to go through. So in the workshop, it goes over to tips to being successful on the exam, different resources that you have or can use in order to approach MedMath questions, as well as sample questions. My mother's a teacher, and she likes to say there are only so many ways you can ask a question, and you'll start to see that really it just becomes about plugging in the different numbers. And once you know the equations and how to approach the question, the exam becomes so much easier. So we recommend to practice as much as you can. Doing a few questions every day is helpful. I understand that you guys are in crunch time because the exams are coming up, but just really taking a little bit of time out of your day to do some of those questions. And try to memorize conversion ratios is the best. It's once you have those ratios from that chart down pat, it becomes really helpful to just plug in those once you know how to approach the problems. Just to be mindful, you will need to be able to perform a lot of these equations without the use of a calculator. And so knowing how to round or how to tackle multiplication or just simple addition and subtraction question, you might need to brush up on those skills because there are no calculators allowed. Some hospitals allow, some don't. In terms of decimal point conversion, every hospital or every school has their own policy. So knowing when to round up and when to round down in an in-ceiling question, that'll be a very specific rounding. And then some of them or some professors will just tell you round to the nearest tenth. So just a little bit about all these different forms. Or terms, conversion ratios basically mean that if you use one ratio and you flip it around, you'll be able to get another number. It's important to understand what the different abbreviations are. So knowing that GM is equal to gram or TSP lowercase would be teaspoon and then uppercase would be tablespoon, milligrams versus micrograms, really paying attention to the minute differences. Sometimes when you get to the exam, things are crazy, but just really taking the moment to break it down for yourself and understanding what the different abbreviations are, as well as the equations. There are specific equations to follow, and so just knowing how to go through there. Some of the questions will be application based. So they'll ask you, what's the difference between IM versus intradermal? So you might have to recognize the abbreviation of the routes, PO, before administering. So there are different steps in order to kind of tackle the question. You'll have some professors who will just put the question out as the word, and then some of them will be like, here's a label and here's words. So just being able to go through read the question first and then reading the drug label as appropriate, really taking the time to think about what is being asked and what is the final unit for what you're searching for. The question might start off in grams, but the professor might be wanting you to answer the question in milligrams. So being able to then go and multiply that all by 1,000 in order to end up with the proper unit. Step 3 is converting the entities in the same unit and making sure everything is the same. So for example, if part of the question is in grams and the other part of the question is in milligrams, making sure everything is in milligrams at the same time instead of using two different units together when they're not the same. Making a chart sometimes is helpful about what information you have versus what you need. So I always like to write on the side, I have this, I need this, and I need this is usually the final unit for what you're looking for. Making the ratio proportion, that's one of the ways to do it, and using the specific formula method and just plugging everything in and going across. And then the last step is to just make sure that you have everything down appropriately. So considering the time of when you're getting things, whether the dose that you received is in the appropriate dosage range, and then it might have given you a total dose and you need to be able to have the hourly dose. So just making sure that, yay, you got to the end, but you're really at the end. Any questions so far? Awesome. So Jane put a whole bunch of resources. Feel free to check them out after. Registered Nurse RN always has great videos. She has great diabetic videos, so feel free to check those out. So the recommendation is to be able to solve by all three methods. My personal preference is dimensional analysis. I cannot for the life of me wrap my head around 1 and 2. I can solve it if you give me the method, but it's not the one that I gravitate to. And so I'm going to focus on dimensional analysis tonight because I feel like it will solve all of the problems, and it's just much easier to approach. But if you have a personal preference towards the others and you have questions, we can definitely go through that after. Ooh, that's a big one. Military time. Try to get your brain thinking on that. If you can turn your phone into military time, it definitely helps. So if we start here, and I'm going to write it down and then I'm going to flip it onto the board. And so we'll go through these together. So the question is, how many milligrams make 3 grams? So the weight, so again, I'm asking myself what I have and what do I need. So I know that I have 3 grams and I want it in milligrams. So here's what I'm going to do. One moment, let me just write this down. I'm a visual learner here. And again, a lot of these are super simple that you can kind of just do the math in your brain, but try to get into the habit of just writing them all out. So it's just much easier when you're going into the harder problems. Okay. Just bear with me. Just stop sharing the screen. Canvas is not like Microsoft Teams. Okay, so the way dimensional analysis works is it says, what do I have? So I have 3 grams, and just get used to that. It could either be written like this, G or GM. So pretend that's not there. And then dimensional analysis says, let's make a proportion. So you're always going to do times. And what is my proportion? And it has to line up like a diagonal. Think back to like the 4th grade there. Oh, you can't see what I'm writing. Hang on. Question is why? Okay, perfect. Oh, I see. So when I'm on the text box, you won't be able to see. Okay, so 3 grams and times. So I need to line everything up. So what I'm going to do is, and it may not line up perfectly because of the way I wrote my text box, it's going to be how many milligrams are in 1 gram, 1,000. Thank you, metric system. Over, so I'm just going to enter it here, 1 gram. So I know that for every 1 gram that I have 1,000 milligrams. And what you're going to do here is you're going to cross things out. And let me get a cool little pen here. And we will make that another color. It will be purple. So grams is going to cancel out. And I'm going to be left with milligrams. And I'm going to multiply across. And your answer is, 3,000 milligrams. So just to go back to the question, to make sure we answered it, how many milligrams make 3 grams? Well, for every 1 gram, I had 1,000 milligrams. So for 3 grams, I have 3,000. And again, that's a question that you can answer in your head. But going back to dimensional analysis, we just line things up and we go across. Any questions on that problem? Okay, let's move on to the next one. The next question states, how many milliliters make 2 liters? So feel free if anyone would like to remind us how many milliliters there are in 1 liter. Feel free to type it in the chat. Awesome. And I love that some of you are writing units. Super helpful. Get into the habit because sometimes you're doing a very long problem and you lose the number midway. So if we were to approach this question the same way, let me just switch to a text box and then we'll cross it out after. Again, you won't be able to see it until I X out of it. So just bear with me. We said 2 liters. So I have 2 liters, but I want that in ml. So we know that there are 1,000 ml, and pay attention to the positioning of how I did this. And the reason why it's important is because you need things to line up. And I know that is for 1 liter. So that's the way I'm writing out my question. And again, I'm going to do the same thing as before. And I am going to cross out my liters because they cancel themselves out. I am left in milliliters. I need one of those stylus things. And if I'm to multiply that across, I end up with 2,000 ml. And that is the answer. Any questions? Okay, let's move on to the next one. How many micrograms make 2.5 grams? So this is another degree further. So anyone can feel free to type out in the chat how many micrograms there are in a gram. And I always think about these in like exponents. So in my head, I'm like 10 to the third is what it would be for milliliters. And then I'll just wait and see if, oh, there we go. Perfect. Yeah. So I do 10 to the 6th. So the way we're going to configure this question, and I'm gonna do it 2 ways. So if you feel like you're never gonna remember how many micrograms are in a gram, we can do that. And so we are going to say we have 2.5 grams. So I'm going to write it out the one way, but if you know that it's 10 to the 6th, then you can just shorten it. So we're going to do 2 steps here. We're going to say that for every 1,000 milligrams, I have 1 gram. And then we're going to say, I'm just going to line it all up in a almost line. And then I'm going to write that for every, well, I'm going to have to do it like this. So bear with me. There's 1 milligram. Okay. Pretend that that is a little further and that there's a little multiplication sign in there that I didn't write, because you can't really re-access your okay, so we are going to go across and we're going to cross things out so we can find out what unit we are left with. So my grams cancel out. And guess what? My milligrams also cancel out because in theory, I lined them up appropriately. What actually happened, they did not line up so nicely. But the important part is that the milligrams is on the bottom because it cancels out right here, and that the micrograms is on top. So feel free to pull out a calculator because we have that luxury. Or if you were on an exam, you would not be able to. So you would be multiplying across. and you would say 2.5 times 1,000 equals 2,500. And at this point, I'm still in milligrams. So now I have 2,500 milligrams and I need to end up in micrograms. So I'm going to multiply that by another 1,000. In reality, you could have just done 10 to the 6th, but if you want to, you can just do it this way if it helps you process things in your brain. And you're doing 2,500 times another 1,000, and you end up with a sum larger than the 2.5 grams. Any questions?
Yeah, sorry.
Yes, go for it.
Where are you getting the 10 to the 6? I don't understand that.
Sure. So what if we go back to the question? The question says, I have grams and I want micrograms. So a gram in plain English is 1. In the way that whole line on the decimal system would line up. A microgram is 1 with 6 zeros. And so we are starting on the line. Let me just draw a line here. So it will make a little more sense. Alrighty. Here is my line. Right over here is 1 gram. Sorry that you can't see the gram part. Right over here, about 3 zeros later, is 1,000 milligrams. Again, these are numbers that are just relative to each other. And then if I were to come right over here, just a little further down, I would say that here is 10 to the 6th. And that's really a microgram. So again, these are all numbers relative to each other. So really, if I wanted to reframe that, I could say, well, I have 1 microgram, and then I would have many, like a smaller number. Yes, it is 10 to the negative 6. Yes, very good point. Thank you very much. It is 10 to the negative 6. So you're going to the left hand of this decimal system. If you were to go into the right hand, you would have macro numbers, which are larger numbers. Did that answer your question?
Yes, thank you.
Not a problem. Alrighty. So moving on to the next question, how many drops makes 1 ml? Anyone have any idea? Yes, so it is 20 drops, and this is not a question that I've ever seen before. It is 20 drops, and I see lots of you know the answer or have the resources on where this question has been found. Again, I've never seen anybody ask it this way. There are drop-related questions that have nothing to do with how many drops are in 1 ml. But I personally do not know the conversion ratio on how to solve for that specific thing, but it would be 1 ml for 20 drops. Alrighty, so going back to the PowerPoint, which should either have been emailed to you or it is located on the Office of Academic Success Canvas page. So feel free to check out our tab there. So here, all of these conversions can be accomplished using just a simple proportion ratio. So there are some of the answers there, and there's your 10 to the 6. But the reason why I kind of made it really long and drew it out is because the same way you're going to answer the rest of the questions is going to be by dimensional analysis. It's a lot easier. Alrighty, so here we go. So we have a sample question on an IV injectable medication. So basically, you have here an order. So I have a patient, let's pretend this is an antibiotic. I have a patient who is written for 500 milligrams of pretend ampicillin, and I have my ampicillin ampule because I'm drawing it up myself and it didn't get sent to me from pharmacy in the amount that I need. And the ampule, the ratio on the bottle, so this is not how much is in the bottle, but inside the bottle it says for every 100 milligrams of ampicillin here, that is 1 ml. It doesn't say 1 ml there because you don't need to write it, but just pretend that it's there. So again, we're going to write what we want versus what we need. Oops, sorry, did not mean to show you the answer there. So we are going to write it out. Let me just write it on my paper here before I switch over. Okay, so again, what do I have versus what do I need? Who can write in the chat box what we have? Awesome. And what do I need? What is the number that I'm searching for? Great. So here is my equation with the bottom part missing because text boxes on Canvas, big blue button are just wonderful to work with. Okay, so the first question I also need to ask myself, going back to those steps, is everything in the right form? So I see milligrams, okay, I'm in good shape. I don't need to do any conversions here. So what I want is 500 milligrams times what I need, and I'm lining that up so that things cancel out. If I were to then cancel them out, what I want times what I need, my milligrams cancel out, and I end up with 500 over 100, which equals 5. And I'm left with ml. So that's my answer, 5 ml. Now I go back to the question. Did I answer the question? I did, because I knew that what I wanted was 500. I had this calculation proportion on my vial of ampicillin, and now I know that I am giving my patient 5 ml. Any questions on that problem? Alrighty, so order, I have a patient, they're written for, maybe their heart rate is just really low, they're written for 0.3 milligrams of adrenaline. What I have is confusing because it doesn't look like it has any appropriate measurements right next to it. So I have something 1 to the 1,000 going on. I feel like if we scroll further down in the question, it might tell us what those appropriate answers are. So it is, 1 second, blah, blah, blah. Let us figure this out together. Okay, so the 1 to 1,000, the first digit represents the number of grams, and the second number represents ml. So if we go back to the question, we have 1 gram for every 1,000 ml. So again, if I approach this question, I look at it and I'm like, what I want, which is the 0.3 milligrams in the ml form, it's not the same as the 1 gram. So something needs to be converted. So what we're going to do here is we are going to draw out our conversion. We are going to say what I want is 0.3 milligrams. But I need to figure this out. So if I write dimensional analysis and I need to try to get to, in order to convert it, I need to get into the gram mode because I need something to cancel. So I know that for every 1 gram, there are 1,000 milligrams. But I'm not done there yet. Then I need to put in the rest of my equation because, again, I am typing out what I want times what I have. And what I have, 1,000 ml over 1 gram. So if we were to line this up appropriately, I apologize for the way things are just all over the place on the paper. So again, I cancel out, cancel out, cancel out, cancel out, and I multiply across. So what I'm going to do is I am doing 0.3 times 1 over 1,000. And you can multiply that however you feel comfortable, which is 0.001 times 0.3. And then I am going to multiply that by 1,000 ml, and I am left with 0.3 ml as my answer. Any questions at all how we got there or what we did? I see a few people are typing, so we will just give them a minute to finish what they are writing. Okay, feel free to unmute yourself. Oh, yes. So how do we know what units they were talking about? Honestly, I didn't know what units they were talking about either because they didn't write it. They need to write the units. If you ever get to a question on the test and there are no units, it's a mistake. So I went through later on to see what units they were talking about when they said 1 over 1,000. So if we go back to the original question, it says the order is 0.3 milligrams. What it had, but it didn't write the unit, was 1 gram for every 1,000 ml. So meaning that in that vial, for every 1 gram of adrenaline, that was contained within 1,000 ml of liquid. So following dimensional analysis, I then put that up all together and I lined it up that way. And I said, if what I want is 0.3 milligrams, I'm going to multiply that by 1 gram over 1,000 because the ratio that they gave me is in grams. And I cannot multiply what I want times what I have because they're not in the same playing field. You can't multiply milligrams by grams. So I needed to convert my milligrams, what I want, into a matching form. And the way I did that was by writing out that for every 1 gram, there's 1,000 milligrams. And it's irrelevant to the number that is there. If I had, let's say, 5 milligrams, and that was what I wanted, I would still put the 1 gram for every 1,000 milligrams because that is the conversion ratio. And then I just multiplied it by the ratio that didn't have units in the question. Did that simplify it? Or is anyone still shaky on it?
Sorry, is that common to have questions like that without units in
No.
exam? Okay.
No. I got to the question and I was like, I don't know. How can you know? Very uncommon. And again, if you get to the exam, raise your hand, ask the professor a question. It could be a mistake. Alrighty. Is everyone ready to move on? Okay, awesome. I'm going to throw in one here just in terms of dimensional analysis. But I don't know if it comes up later, and I'd rather be done with this section. That way we can focus on IV questions, which are everyone's favorite part of MedMath. So we are going to make up a question right now. I am going to say, I have a patient who is, hang tight on the question. I have a patient who is 55 pounds. How many kilograms do they weigh? So following dimensional analysis, the way I would do this is I would multiply it by my conversion ratio. And again, everything needs to be lined up to cross out. So I know for every 1 kilogram, it's going to equal 2.2 pounds. And if you are having a hard time wrapping your head around this, think about when, or if you've traveled internationally, you go to weigh your suitcase that you know is overweight. You might be like towing the line at 55, and suddenly you put it on the scale and you're like, oh my gosh, it's 24 and a half. That's because the kilogram is always going to be smaller than the pounds. So just use that as like a final check in your mind when you are doing your pound to kilogram conversion, just to figure that out there. So again, dimensional analysis, I cross things out, I am going to see, yay, I lined them up. So what does that mean? It means that my patient's weight in kilograms is going to be 55 over 2.2, and my patient weighs 25 pounds. This is a very real weight for me. I am a pediatric nurse, and so I'm used to seeing these small, not pounds, sorry, kilograms. I'm used to seeing these small numbers. The question will usually not stop here because the NCLEX and your professors are assuming that you can convert pounds into kilograms. It'll then flip it into a med question, and then might be like, oh, is this medication in the appropriate limit? So it might tell you that it isn't, or let's do a Tylenol question. Tylenol, the American Academy of Pediatrics says that you can do 12.5 milligrams per kilogram. We'll make it easier and we'll say ibuprofen is 10 milligrams per kilogram. So if my patient is 25 kilograms and I know that the ibuprofen dosage is 10 milligrams per kilogram, what is an appropriate dose for my patient? I am going to just follow along on dimensional analysis, and I'm going to say, if my ibuprofen ratio is 10 mgs per kg, I'm going to do 10 milligrams over 1 kilogram. And again, you'll be flipping this back into Tylenol, but not Tylenol, to milliliters, but we don't have that yet. So I would then say that my 25 kilogram patient, an appropriate ibuprofen dosage for that kiddo would be 25 times 10, and they can get 250 milligrams of ibuprofen. Any questions on that? And again, you want things to cross out. You cannot sometimes, again, this is not all the time. Sometimes professors will give you a paper med math exam. In the hospital, you get sometimes a paper med math exam, but most of the time, your med math exams will be on ExamSoft or another online exam platform. Sometimes professors haven't figured it out yet that there is a built-in calculator function, but most of them disable the function, and so I wouldn't rely upon it. Alrighty, moving down the PowerPoint. I'm just going to ignore the insulin component. Just know that you can mix insulin types, and that insulin goes according to the half unit. It is a very serious medication. It's a 2RN check. So in some hospitals, as we talked about before, you might be required to calculate what's called a drip rate. On your exams, your professors will refer to macro drip versus micro drip. So I know it is going to be the reverse here. So micro is going to have the larger amount of drops, and macro is going to have the smaller amount of drops. The logic behind it is that the tubing is going to be either much smaller, and so what happens is that it has to drop more times in order to get an ml. And in macro drip, the drips are just flowing more freely, and so you have to do less drops per ml to accomplish that 20 drops per ml, which we talked about before. So going back to the formula that we had written out before, I'm going to put it up. The IV drop rate not the IV per milliliter rate. The IV per drop rate is, and feel free to write this down, but I will also copy paste it into the chat. The volume to be infused, so volume is always in milliliters, over the minutes to be infused. And remember, that's minutes. It is not hours, but minutes, times the drop factor. And the drop factor, drops, are always GTT. And your answer will always be in the answer of GTT per ml. And this formula is not to be confused with the IV ml rate. I will just put it in the chat if you are writing all the things down and you want them side by side so you can compare there in the chat. Okay, let me just write my formula down. And when you get to a drop factor question, write the equation down so you can just put things in. So I'm writing on my paper, volume to be infused over minutes to be infused times the drop factor. Which is always going to be in the GTT per minute. Okay, so let's go to the question and let's plug things in. Okay, I read the question. Here we go. 480 milliliters of IV fluid is going over 120 minutes. So whomever wrote this question was very nice and didn't say 2 hours. So if it were to write 2 hours, you would need to convert that to 120 minutes using macro drip. And so if you go back to the chart, which I don't know if you guys have access to it, but I will try to share that as well. Macro drip is not just, it has options. So it can be 10, 15, or 20 GTT per minute. So if the professor wants a specific macro drip, then they have to tell you. Micro drip is always going to be 60 GTT per ml. So in this question, they're telling you that the drop factor is 10 GTT per minute. So we are going to line this question up. Again, volume to be infused over minutes to be infused times the drop factor. And let us write it out in dimensional analysis. Our total, or volume to be infused, is the only volume that they had written, and it is 480 ml. It is going over the only minutes that they had written, 120 minutes. And I am multiplying, oh, sorry about that, very not straight line. I apologize. And I am multiplying that once I find the answer times GTT per minute, which is the drop factor, and we said it was 10. 10 GTT over 1 minute, where it's per 1 minute. So it's like 1 minute. So let us start start plugging those in on your own and see what answer you come up with. Awesome, I see an answer in there. Okay, so for everyone else who's still working on it, keep on trying to figure it out for yourself. But for the sake of time, I will do some dimensional analysis for you. So if I just look at this, I'm crossing out my minutes and my minutes, two of the same, they go bye-bye. And I am left with a milliliter and a GTT. And if I do the math, 480 ml divided by 120 is equal to 4. So if you need to rewrite the equation on your paper because you need it to look clean and you need to know what you have, you could do 4 ml per minute times 10 GTT over 1 minute. If I were to write it that way, then I can cross things out here and you will still be left with the 40 GTT per ml. I meant minute. I'm sorry. No, I did not. I did mean ml. Any questions about drop factor? Okay, so we did all that. Alrighty, here is the next question. Try to plug it in on your own and then type in the answer and we'll briefly go over it. Just to read the question out, we had 300 ml of IV fluid going over 60 minutes. Again, it could have said 1 hour, in which case you would need to know that 1 hour has 60 minutes using micro drip. And micro drip here, again, think the reverse. So micro drip here is going to be the 60 GTT per minutes. The equation to solve it is in the chat bar. If you can't find it, it's volume to be infused over the minutes to be infused times the drop factor. And the drop factor here is 60 GTT per minute. And again, the answer that you want to come out with is going to be GTT, so drop per milliliter. So good question. The drop factor is not always given. The only time the drop factor will be given is when it is the macro drip. Awesome. So it looks like you guys got the right answer. So just to do a brief just a little overview, we have the volume to be infused. 1 second, let me just read that question there. So units do have to be the same, and I'll show you. Let's just go back quickly to how that worked out. So on the top part, it appears that it doesn't work out. But if I break it down to the bottom, if you look at the bottom here, it ends up canceling out. And so that's how they end up being the same. And your answer will be GTT per ml. You already have the drop factor, which is GTT per minute. Alrighty, so quickly just to go over this one, we have our volume to be infused 300 ml over our minutes to be infused, which was 60, right? Yes, 60. And I'm going to times, I will click on this soon so you all can see it. I'm going to multiply it by the drip factor, which was micro drip. So it's 60 GTT per minute. And if I go across through that, you will end up with the answer, which was 300 GTT per ml. Any questions? Okay, so we're not going to go through the next question, but just see here where it says 2 hours, you got to multiply that out and you're going to get 120 minutes. Do keep in mind here, these are trick questions. So where it says 400 milligrams of ampicillin, don't think that that is your total volume. It's 400 milligrams of ampicillin diluted in 250 milliliters. That means that the whole vial has 250 ml of fluid, but that is not your total. So, oh no, that is your total. Basically, no, what I meant to say was when it says available 1 gram per 10 ml vial, the way it wants you to approach the question is to really break it down step by step and say, okay, what does it want? It wants the drop rate using macro drip, micro drip, and infusion pump. So this is going to say, can you figure out milliliter per hour? And can you figure out the other one? Anyone have any idea on how to approach this question? And I'm sorry, you all were correct before. It is GTT per minute. Your drop factor is GTT per ml. So just fix that on your notations. Alrighty, so the way we would approach this is we would see, well, I have ordered 400 milligrams of ampicillin. What I have is for every gram, I have a 10 ml vial. So I need to first calculate my my drug ratio. So if we go through the answer here, just know that for micro drip, that's our 60. For macro drip, it would either be 10, 15, or 20. And here they're designating that macro drip as 10. So we are going to flip up right here. So again, we needed to determine what the milliliters are. So if we go back to our notepad right here, so usually they should say, just to answer that question about macro drip, they really should say whether it's 10, 15, or 20 they want. Some professors will specify that when they don't say it, this is what they mean. I see in this PowerPoint, they're under the assumption that they would like it to be 10. So you can stick to 10, but I would ask your professor because the general rule of thumb is that they should tell you. Alrighty, so what I want is 400 milligrams times. So again, you can either write this out fully or you can just think about it proportionally. I know that for every 1,000 milligrams, there's 1 gram. And that for every 1 gram, it's going to be 10 ml. So let me write that out for you. What I want is 400 milligrams. Any questions on how I wrote this out? So you can go across and do the math yourself. And so if we go across, we are going to say 400 divided by 1,000 times 10, and I'm going to end up with 4 ml. So in 4 ml is going to be 400 milligrams of whatever medication they ordered. So when I add that 0.4 ml to my diluent, so the 400 milligrams, I don't just give that to a patient. I need to dilute it in another fluid. And what is that fluid? Sometimes it could be normal saline. Sometimes it could be D5.5. So here it's D5W. I am diluting this in a whole bunch of sugar. And so what my giving the patient is going to be 250, and that amount is pretty insignificant. We are not going to count it in the total there. And so if I put out that equation into my drop factor, it's going to look like this. My total volume, my volume to be infused, it's a bag of 250 ml over my minutes to be infused, and the problem told me that they wanted it over 60 minutes. Let me just make sure, was it actually 60? Yes. Over 60 minutes. And I'm going to multiply that by the drip factor, and they told us that that was 10 GT minute. And so what I'm going to end up with, if I multiply that across, is, does anyone have the answer? And again, round up because of where your decimal should fall. Your answer is going to be 41.6 GTT per ml. But that is not enough. If you put that answer on an exam, it will be marked as wrong, or your professor might be really nice and you might get partial credit. You need to round up. You are above the half a point decimal. You're going to round it up to 42 GTT per ml. Now, what if you needed to plug this into a pump and you had that luxury and they wanted it in the IV formula per hour? I would look at my total volume and I would say I have 250 ml for every 60 minutes. So it's going to be milliliters per hour. That is going to be 250 ml per hour. If the problem read over 2 hours, then I would do my total volume over my hours to be infused, which would be 2 hours, and I would get an IV fluid rate of 125 ml per hour. Any questions? We will do one more question before we end for the night, and then I will leave the rest of the time for questions. We'll also be switching over to open tutoring hours, so feel free to hop on there as well. No, the amount is very negligible. We wouldn't count it. Alrighty. We have here our order. Our order writes for Lasix. So we have a patient in fluid overload and they're in the hospital with pulmonary edema, and we have them written for 100 milligrams of Lasix. It happens to be that my Lasix is diluted in 100 ml per hour. But the way I am going to configure this is that I know in my head that the pharmacy has told me that 10 milligrams per hour is the appropriate ratio for this medication to be given to the patient. And they want me to calculate the rate at which the medication is given in milliliters per hour. So feel free to try to tackle this on your own for around a minute and a half, and then we will go through on how to answer it. Again, what you want is 100 milligrams per Lasix in the appropriate administration rate of milliliters per hour. Alrighty. I hope everyone had a chance to attempt to answer that. So what I have here is I have 100 milligrams in 100 milliliters. So you can either put it there or you can put it a little elsewhere. And I know that my medication needs to run in the appropriate formulation of 1 hour over 10 milligrams. So I didn't put ml in this chart. You can put it wherever you want, but just think about it this way. If my goal is to have 10 milligrams every hour infusing, and here the 100 milligrams are synonymous with the 100 milliliters that are going. So just loop those two together. If I go across here, I do 100 over 10, my milligrams cancel out, and I am left with 10 milliliters per hour. I would give this patient 10 ml of Lasix per hour, which in essence is also 10 milligrams per hour. Any questions at all? We will go through more med math questions in open tutoring. I just have to switch over the canvas. So let me know if anyone has any questions. Feel free to type them in the chat bar. This has been recorded, so feel free to watch the recording later. And again, I will touch base with Jane, but the document should be available on the Office of Academic Success Canvas page.